Okay, here's an example. Finding an Euler path for the graph. It wants me to find an Euler path and enter your response. Okay, so the key point on this example is to always number the vertices as far as how many edges. So one edge, right? There's only one edge coming into that point. How many edges here? 3, right? There's 1, 2, 3 edges coming in here. How about here? 1, 2 edges and 1, 2. So we always put the numbers by every point that show how many roads are coming in. So how many roads coming into A? 2 roads. How many roads into B? 2. 3 roads into D, 1 road into C. So that's the number of lines that hit every point. Okay, so once we have those numbers down, what's important, an Euler circuit, remember an Euler circuit, that's not what we're dealing with here, has all even. And that's not, because this one and this one are both odd, aren't they? So an Euler path has only 2 odd. So this is an Euler path. And here's the key point. It must start and end at one of the odd ones. Let me put a box around that. Make sure you know that very well. It must start and end at an odd vertex. It has to. It won't work any other way. So make sure you know that point for the exam. So that means you can start at D and go bloom, 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 bloom. See that? And back to C. That worked, didn't it? Right? Where we covered every line once. Or the other option is you could start at C and go boom, 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 boom. See how those both work, meaning they cover every line without any repeats. They cover every line exactly once, like a street cleaner going over every street exactly once, or a post office man delivering postage to every street exactly once. That's the whole point of this Euler stuff, is that we want a route where we go over every line only one time, not twice. We don't want to double up. That's a waste. So businesses, garbage men, street cleaners, post office delivery, they want routes where they can go over every street exactly one time. And there's not always that route possible. And so how do we find it? Well, an Euler path is when you have only 2 odd numbers. You got to put the numbers down first. And you must start and end at odd. So that means you can start here and end at this one, or vice versa. It doesn't really matter. Maybe I'll swap it up to be interesting. I'll start here and I'll end there. So let me do it one more time. I'm going to start at D and I'll write it down as we go. D, and you can do whatever you want. I'll go A, B, back to D, and out to C. See how I started at D, ended at C, because those are the odd guys, right? D and C are the odd guys. You got to start and end at those. So that would be an answer. There's other answers that are possible as well, right? I could have reversed it. Again, I could have said, well, I'm going to start out here at C. I'm going to go D, so I'll say or C, D, B, A, back to D. Again, see how we start and end at the odd ones, C and D. And there's other ways of mixing it up in between. Now notice it doesn't work unless you start at C or D. Let me show you. What if we tried to form an Euler path here, and instead we said, I'm going to start at A. Here we go. All right, remember the street cleaner, post office person, right? Garbage man wants to deliver every street. Boom, boom, now you're in trouble. If you go this way, how are you going to get over to this street without backtrack right there, right? And then you could finish, because you had to backtrack. You didn't cover every street exactly once. If you go this way, then how do you get over to this street? Do you see the problem? Yeah, it's because I tried to start at A, which is an even number. That's not going to work. You must start and end at odd when you're doing an Euler path. You have to start and end at odd. Here, let me do one more just to make sure this is super clear for you. How about, let me do one more important map here. So I'm going to go, well, actually, I'm going to go C, B, D, E, F, A. All right. And I'm going to start connecting. So C goes to everybody but E. Boom, 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 boom. And B goes down to E. Boom, like that. Kind of missed. And A goes to everybody but F. Boom, and boom. And F goes to D. Boom. And E. I'm just making up a problem right now. Like that. And all right, there's the example I want. Let me make this a little bigger so it looks right. All right, so there we go. So same question. Find an Euler. Well, you tell me. Is there an Euler path here? An Euler circuit? Let's do the numbers. Start wherever you want. Start at A. This is 3, right? There's 3 lines hitting at A. How many lines hitting at F? 2. How many lines hitting at E? 3. How many lines hit D? 4. How many hit C? Looks like 4. 1, 2, 3, 4, right? How many hit B? 2. All right. So what do we have? We like the even ones. So we have, this one's odd, A is odd, and E is odd. So 2 odd, so that's an Euler path, right? Euler circuit is all even. We don't have an Euler circuit. There's no Euler path, and you must start and end at the odd ones. At the odd. So let me underline that again, and doing all I can to make you know this really well for the exam. Make sure you know this. You must start and end at odd. So the odd ones would be A or E. So you must start and end at A or E to make an Euler path here. So again, that's like the street cleaner that's going to clean every street, post office person can deliver to every street, garbage man, every street. You want to do every street exactly once. That's efficient. You don't waste time and money. Businesses care about this. So you could start at A, for example. And there's going to be an Euler path. So here we go. I'm going to list out the Euler path, which means hit every street starting at A. So we go boom to C. So A to C, to B, to E, to D, to C, to F, to D, to A, one more street, back to E. See how we covered every street exactly once? Perfect work by the street cleaner, the garbage man, the post office delivery person. We started at an odd A, we ended at an odd E. You must start and end at the odd ones. If you tried to do this, starting or ending at an even one, it wouldn't work. Euler path, you must start and end at an odd one. So that's the point of this